entirely of monobehaviors. Large projects become chaotic. Developers suffer. One man has the answer.
Good morning, Unite. My name is Richard Fine. I work on the sustain engineering team at Unity. We deal with all the versions of Unity that have been released to the public. We deal with patch releases, and we deal with 11th hour Hail Mary plays to help ship-stopped projects get unblocked and get out to the world. I want to talk to you today about some of the horrible situations I've seen from bad decisions made in projects. I want to show you an important tool that will help you avoid some of these horrible, horrible things. So, what am I going to talk about today exactly? Firstly, I'm going to talk about some of the problems with monobehavior as a class. I'm going to talk about ScriptableObject as an alternative to monobehavior. It's another way of doing things, another important element in your architectural toolbox when you're working in Unity. And I'm going to walk through a bunch of examples. Okay, we've got kind of examples just on the slides with like abstract things, and I've got like a nice live demo as well, applying some of this stuff to one of the projects. So let's start by looking at monobehavior. Why is it bad? Well, let's start with exactly what we're talking about when we're saying the use of monobehavior. So we're talking about projects where we've got a bunch of scripts, they're all written as monobehaviors, they're all attached to game objects. They all live in the scene, or they live on prefab files. They store all of your state. So all the variables that you're changing and so on, you're keeping all of them in monobehaviors, or the vast majority of them. And you get callbacks and things like that. Update, late update, start, awake, on enable, on disable, on became visible, on application quit. Okay? So hopefully this is a familiar situation to most of you. This is how most Unity projects, at the very least, start out. It's how a lot of them end up. But there's a lot of problems that happen when you build a project kind of just in this way, when you just apply this one technique over and over and over, and you build everything up in this way. So the first problem comes when you're dealing with shared versus non-shared state. And what do I mean by that exactly? So here's a little example of like an enemy component. And you can see a few different variables there. Current health, time until next attack, maximum health, an array of different pain sounds to use when the enemy takes damage or something like that. But the thing is that in most projects, you don't have like a unique maximum health for every single enemy. You don't have a unique set of pain sounds for every enemy. All of your goblins have the same set of sounds, have the same set of health, and so on. You don't want it to be different because that's confusing to players. You want a sort of a consistent shared bit of information for a bunch of objects, and some per instance information as well. And the way that most people write monobehaviors combines all this information together into one place. So that's what I'm talking about when I say shared versus non-shared state. You've got some information that you want to be kind of using across multiple objects, multiple instances, and you've got some information that you don't. The current health for an enemy is definitely something you want to be on that enemy only. The second problem that people run into with monobehavior is that any changes you've made in play mode get lost when you exit play mode. This is obviously pretty important that we don't just keep the fact that you moved all the objects around and killed all the enemies and the player got to the end of the level instead of the beginning of the level. You want to restore a lot of that state. But there are times when you're changing things in the middle of gameplay, trying to tweak, trying to iterate, and it's a bit of a problem that you then lose all that information when exiting play mode. So that's another thing that's bad. The next problem is that monobehaviors have subfile granularity. And what do I mean by that? I mean that when you have a monobehavior in a file, and I mean a scene file or a prefab file, it's not the only thing in the file. In the case of a scene file, you've got a ton of other objects in there as well. In the case of a prefab file, you've got other components, you've got game objects and transforms, you've got a lot of other potential information in there. And this is pretty bad when it comes to collaboration. If you want to edit a monobehavior in one scene file, then you're having to potentially lock the whole scene file. Or at the very least, you're making changes that other people on your team may be changing other objects in the same file. And then you're having to kind of risk having merge conflicts when that all comes together afterwards. It would be much nicer from a collaboration point of view if one object meant one file. So you could lock things and operate at the same level that the VCS expects you to operate. And then the other problem that happens is callback chaos. And this is where you have monobehaviors throughout the place, subscribing to update and fixed update and so on. And in any given frame, you find it really hard to keep track of what's actually happening. You can't easily keep track of which code is present in the scene, which code is being executed. You can kind of look through and sort of find where your callbacks are. But when something is changing and you don't know what's changing it, potentially any component somewhere has had an update method show up on it that you didn't see about. Kind of thing. So one of the solutions people have applied to this for quite a while is to use uninstantiated prefabs. And what I mean by that is having a prefab that has monobehaviors on it, but you don't actually put in the scene. Because it's not in the scene, it doesn't get any callbacks. And it can sit in the project, and it can be a place to store shared state. So you have your non-shared state in the scene, your shared state on prefabs kind of kept in the project. And yeah, this does kind of work, more or less. But it's kind of not really what a prefab is. I mean, having shown this to some of the founders of Unity, they're sort of, people really do this? Wow, that is not what we made those for. So yeah, you can do it, but it's not what prefabs are for, really. And I mean, that might seem like a conceptual objection, but it's also, it's confusing then to artists and designers that they have like some prefabs that they should be dropping into the scene and other prefabs that they're supposed to not drop in the scene and things like that. It makes it slightly more confusing to understand the way your project is set up, that you have some of these special prefabs in some places. And the second problem then as a result of that is that they're kind of accident prone. It's quite easy to accidentally drag and drop one of these things into the scene. And then suddenly you've got the shared object in the project and also the instance in the scene. And that can become very confusing very quickly. It's also possible to accidentally add extra components to these things as well. So suddenly your prefab that stores your enemy maximum health information also has a rigid body. Why? Because nobody knows. It just sort of happened at one point and someone checked it in. It wasn't supposed to be like that. But now, especially on platforms where stripping is in effect, now you're accidentally bringing in the physics system or something like that when you're building for WebGL. And it allows this sort of accumulation of mistakes and things that it would be better to just avoid having that in the first place. And the other thing about using prefabs for this is they still have subfile granularity. Even if you have a prefab that just has a single monobehavior on it that you keep in the project, it still has a game object and a transform in that file as well. And maybe you never really touch those, but it still means that kind of when you're looking in the file, there's extra data in there. There's the extra overhead when you're loading it. It's extra stuff. And as game programmers, we like to be efficient with things. We don't like having redundant extra objects kind of just hanging around for no reason. The other approach that people will sometimes take to dealing with shared state in particular is to use C# statics. So to have a bunch of static variables and you store your shared information in there. And that also works. You can do that. But it's very, very DIY. So the first problem is that there's no serialization support for that at all. If you want to kind of store maximum enemy health in like a static int max enemy health variable or something like that, it's going to be completely up to you how you fill that variable out and loading and saving that information. There's also no way to visualize that in the inspector. You have to write custom editors that will read your statics and kind of show you in the inspector what those look like. And they all get lost whenever you reload the domain as well. So if you try and do support for recompiling in play mode, all your static data gets wiped out. So you can do these things, but you have to kind of roll a lot of support around it yourself. And you're using an engine like Unity because you don't want to roll your own support for all of these basic fundamental things. So let's talk about ScriptableObject. It's monobehavior, Jim, but not a component. That's actually quite literally what it is on the engine side. We use the same class to represent ScriptableObject and monobehavior, except that a ScriptableObject isn't attached to a game object. That's literally all it is. So you can have your own custom class, your own variables, your own functions, make an instance of it, but it doesn't have to be attached to anything. It doesn't have to have a game object in a transform. It doesn't have to live in the scene. It can be wherever. So it can't be attached to game objects or prefabs at all. It does not get callbacks. And this might seem limiting at first, but when you consider the callback chaos situation people can end up in, this is also kind of a blessing. You know that if you have a lot of your objects built as these things, they're not participating in what's happening from a frame-to-frame basis, so you don't have to kind of reason about them. If something's going wrong, you can kind of just rule them out pretty quickly. You know, it's not the scriptable objects that are doing something every frame because they don't do anything. And they can be serialized and inspected, just like MonoBehaviour. That includes writing custom editors, using property drawers, etc. You know, it's a fully understood object within the Unity ecosystem. So we'll talk about now how ScriptableObject solves some of the problems that we were talking about at the beginning with MonoBehaviour. So firstly, in the matter of shared versus non-shared state, kind of mixing together these things. Having ScriptableObject really encourages a strong separation of this stuff. So usually people end up using it for shared state only. So you have a MonoBehaviour that stores your non-shared state, your per instance state, that might then reference a scriptable object that holds all the shared state kind of left over. Again, you can do this with MonoBehaviours or with prefabs and so on, but ScriptableObject really kind of encourages this way of working as a pattern. So it helps guide you into a best practice. When it comes to resetting objects when you exit play mode, you can have scriptable objects that don't live in the scene, but live in the project instead, and so they don't get reset. Only the things in the scene get reset. And this allows you to tweak all the values in a scriptable object during play mode, exit play mode, and they're all kept. So if you're keeping all of your timing and gameplay tweaking parameters in a scriptable object, you can tweak on the fly during play mode, exit play mode, and none of your work is lost. It's all there, it's all kept. The matter of subfile granularity. How do scriptable objects live in files? Well, you have total control over that. You can have a .asset file in your project that contains exactly one object, a scriptable object. You don't have to have extra game objects and transforms hanging around. You can pack several scriptable objects into one asset file if you want to. It's up to you. We have the APIs to let you kind of do all of that. And I'll show you how some of that works later on. And lastly, callback chaos. As I said, they get basically no callbacks. They get on-enable, on-disable, and on-destroy. And that's it. So because they don't do anything, it's a much lower cognitive load for you when you're trying to debug, when you're trying to understand what is happening. You can just ignore these things. They don't do stuff unless you're making them do stuff. So we'll look quickly then at just what it looks like to kind of declare a scriptable object and work with it from code. So that's what it looks like to create one. It's very, very similar to MonoBehaviour. In fact, it's almost identical. You can see the only difference is the base class there. Instead of it being MonoBehaviour, or Unity engine.MonoBehaviour, it's Unity engine.ScriptableObject. That's the only difference. Beyond that, you're declaring variables in exactly the same way as you would with any MonoBehaviour. And then referencing one also looks like referencing a MonoBehaviour. You just have a variable of your class type, and it will show up in the inspector. It will let you drag and drop in instances of scriptable object. It serializes, it deserializes, it does the works. It does everything. It's great. So you get kind of the same way of working with objects and assets that you're used to when dealing with textures or materials or MonoBehaviours or game objects or anything else, any kind of object in Unity. It's just another one of those. Unity treats it like just another one of those. So how do you create these things then? If you don't attach them to game objects, there's no add component. There's no kind of going to the components menu and pulling it from there. How do you actually get one of these objects made to work with? So there's a couple of ways. So firstly, you can create these things kind of just in memory using create instance on ScriptableObject as a static method. So this is kind of like your add component, but there's nothing to add it to. So you just create one of these things. It's free floating in memory. It's an object that exists. It's the same as doing new material or something like that. In theory, we could have done this as a constructor. I don't know why we didn't. Historical reasons, I guess. Once you've made one of these things, you can also bind them to an asset file in the editor. All the asset files that you create, all the custom assets you create, they have to have the .asset extension. But having made one of these things, either using assetDatabase.createAsset or using assetDatabase add object to asset, you're then able to kind of pack these things in. So this is how you have the control over how these things are put together. You can just have one object in a file, or you can kind of keep on packing extra objects into one asset file, whatever suits the kind of the situation you're working on, whatever suits the way of thinking about the problem that most makes sense to you. And you can automate all this as well. In 5.1, I think, we added this create asset menu attribute. And this makes it super, super easy. You stick this on your Scriptable object class, and then it will show up in assets create. And you pick that, and it will make an instance of the object, bind it to a whole new asset file, and then there, you're done. Simple as that. And you can customize the file name and the menu item name and so on with parameters on the attribute. But simple as adding that one string, and you've got instant kind of custom asset support in your project. So the callbacks that ScriptableObject gets, this is going to be a very short slide. Firstly, we get onEnable, and we get this when the ScriptableObject is first created, so before create instance returns, or we get it when the object is loaded. We also get it after a domain reload. So when scripts are recompiled in the editor, at the end of that process, when we finish reloading everything, any scriptable objects that exist in memory get onEnable to kind of warm them back up again. We get onDisable, which is called when a scriptable object is being destroyed, or before it's being destroyed, and also before we are shutting down the app domain for assembly reload. And we get onDestroy, which happens when it's destroyed. The name is pretty good there. And that's it. That's all you actually get on a scriptable object by default. So there's not a lot to learn. You can see that most of the things that these things might do on their own is going to happen around, startup time, reloading the app domains, and so on. The rest of the time, per frame basis, frame to frame, they just don't do anything unless you tell them to. You can add your own functions to a scriptable object, of course, just as you can add your own functions to a MonoBehaviour, and you could call those every frame if you wanted to. But there's no kind of magical, oh, I put this thing in and it happened to be called update, and so Unity is calling it every frame and stuff like that. There's no magic methods beyond these three. So that's that. So let's talk a little bit about the life cycle of these things. I've shown you how they're created. What about after that? So it's pretty much the same as any other asset. Once you've made a texture or a material or something like that, the life cycle is the same as those. As long as you still have it and you're continuing to use it, it's going to stay alive. The point at which it usually will go away is when you call resources unload unused assets. And this is where we're going to scan through all of your MonoBehaviours and objects in the scene and see which things are referencing, which other things, and work out this scriptable object that you created is no longer being referenced by anything. So we're going to get rid of it. And you have some control over that. You can stop that from happening using hide flags, and we'll talk a little bit about a pattern that you can create with that later on. Just a little note then on destroy and DestroyImmediate, because this is the other thing that people will sometimes do with scriptable objects to get rid of them, just as you can do with a material or a texture or whatever. It's important to remember Unity is not a .NET engine. And this is something that sometimes takes people a little while to get their head around. It's not a .NET engine. It's a C++ engine with a .NET layer. And what this means is that a lot of the objects, well, pretty much all the objects in Unity, they have this kind of dual personality thing going on. They have a C++ representation, and they have a .NET representation. So I've got my scriptable object that exists in memory right now. And there's part of it that exists in managed land. And that's the C# class that you declared. Okay? And there's also a part of it that exists in C++. And for all scriptable object instances that you ever create, we have the same class on the C++ side. It's actually the same class as we use for MonoBehaviour. And the C++ part takes care of the identity of the object. It provides things like the instance ID. It takes care of referencing. It takes care of serialization. It takes care of making it available in the inspector, things like that. Now, when you call destroy or DestroyImmediate, people assume that that kills off the whole thing. That's not what happens. Oh, yeah. So you've got the C# part. It has a reference to it from some other field. So when you destroy this scriptable object, what actually happens is we kill the C++ part. We cannot kill the C# part. There is no mechanism for immediately destroying an object in C#. The closest you get is something like iDisposable, but even that doesn't actually destroy the C# object. It tells it to kind of clean up its stuff, but the object itself is still kept around in this disposed state until all the references to it are gone. So this is a common problem people will run into sometimes, not just with ScriptableObject, but with any kind of asset that has this scripting component and a native component, which is all of them. Having destroyed it, the scripting wrapper, the managed part, can be still kept around by that reference from some other field. The only way to actually get rid of that C# part is to make sure nothing is referencing it anymore and then let the GC run. And the GC will eventually clean it up at that point. So when you're destroying things, it's a good idea to also null out the references that you've got. And don't be mistaken into thinking that if it appears to be null, then it is null. Because that's another thing that we do in Unity, is if you've destroyed the C++ part of the object, we will pretend it's null. And this can make for some nice things, but it also leads to some horrible problems. So be aware of that one. So that's kind of all there was about ScriptableObject itself. It's a pretty simple class. I think there's one page about it in the documentation. And this is why a lot of people don't know about it. They kind of just sort of scan through and miss it. And it's like, you can make an object and just like have it sit there. It's like, oh, OK, I'm going to make rigid bodies now. Just kind of sort of forget about this thing because it's so, you blink and you miss it. It's so simple. But simplicity is a good thing in our architectures. We want simplicity. We want to use really basic objects that don't do very much so that it's less to think about. So let's look at some patterns that we can do with this stuff. So the first and most common one is to use these things as completely pure, inert data objects. So we're talking about having a class bound to a .asset file, maybe, that just holds data, holds shared state, usually. So I've got an example here of like a drop table for killing a goblin in an RPG or something. So we've got like 3 potential objects it could drop, and the chances for dropping these and so on. So we can share all this information between every goblin in the game. We say, whenever you kill a goblin, these are always the drops that you get from that. And we could, for one particular goblin, maybe say, OK, well, we're going to make him use a different drop table. But we don't have to kind of set up the whole drop table on each one individually. We don't have to copy it all whenever we instantiate a goblin. This is also a demonstration of using property drawers and custom editors to produce a slightly nicer user experience. You can see I've got sliders for that chance there. That's just sticking the range attribute on a float, because actually what it's storing is just a float between 0 and 1. But putting the slider in there means that this is slightly more nice for a designer to go in and just tweak what the drops are for a standard goblin. One of the approaches people could use to this as well is to use like a real database, to go and use SQLite or something like that. And that's a valid approach, but using ScriptableObject instead, it's got a bit less overhead than that. You don't have to deal with kind of setting up the SQLite database and loading it and kind of getting it all in place. And it's a smoother UX as well. Your designers, your artists, they can edit all this stuff in exactly the same way as they edit any other object in Unity. And it's using familiar UX paradigms. It's completely standard. And referencing these things works very smoothly as well. With a standard database, you have to get some way of identifying kind of which row in the database to work from. I haven't yet seen anybody come up with like a nice solution to just being able to drag and drop this row of the database into this object here, please. Scriptable objects will let you reference them just like any other object. So the next pattern, the one that I quite like, because it's sort of counterintuitive, is to have empty scriptable objects that you bind to asset files. And you might think, well, what's the point of an empty object? What can you do with an empty object? You can't store any data in that. What you can do with an empty object is you can compare it. You can test equality on an empty object. So that means you can use these things as dictionary keys, for example. And this is very similar to what you do with an enum, right? In principle, when you have an enum, you've declared your different values. You're not supposed to do arithmetic on them. I mean, you can, but it's kind of not what enums are about. The only things you can really do with enum values are compare them and say, is this equal to this enum value that I'm expecting, or is it something else? And you can do exactly the same thing with these. But the key advantage here is that your designers can add new values to the enum without changing any code. Once you decide that actually it would be helpful to have some information associated with these things, there's also a very natural extension to go from these empty scriptable objects to a non-empty scriptable object. So maybe having created all these different damage types that exist in my game from different weapons and different attacks and so on, maybe I want to add a bool for kind of which ones the player is vulnerable to or something like that. So I could add that in one place and then just go through all these damage types and just check the bool on or off, instead of having to have a separate lookup somewhere from each of these to the corresponding bool values. It's usually faster to kind of put the data on these things directly. And that's something you can't do with enums at all. You can't really kind of add extra data to each enum entry very easily. The other thing you get with this is null support. So with an enum, you might need to introduce like a sort of a nothing entry or something at the beginning. With this, nothing is just null reference. And that ends up working really nicely for a lot of situations. Okay, so let's look at one that's quite dear to my heart. Dual serialization. So scriptable objects are fully supported by JSON utility, which came in 5.3. So you can make a scriptable object, and you can use JSON utility.toJSON to get instantly, very quickly, a string with all the serializable data in that scriptable object that you can then save to a file or things like that. And this means that, and you can deserialize them as well, of course. I think you have to use from JSON overwrite rather than from JSON, but you can make an object and then use overwrite to fill it with data that you got from JSON. And what this means is that having built a system that works with scriptable objects, you can mix objects that you created at design time, that you saved into asset files in your project, with objects that you've created by deserializing JSON. What might you do with that? Well, a pretty good example would be something like user-made levels. So given a scriptable object that stores all the information, I mean, suppose I have a simple platformer. I've got some platforms, I've got some enemies, I've got some coins to collect, and I've got a player start position. And the game is you collect all the coins, you avoid the enemies, and once you've got all the coins, then the level is done, you go to the next one. Now, I don't want to ship my game with no levels. I want to make a bunch of levels in the editor, ideally using the scene view, using the standard tools I'm used to. So I do that, and I write a very simple editor script to kind of collect up all the things in the scene and pack them into a scriptable object for me. So I can have a bunch of object assets just sat in my project that I'm going to ship in the game, built in. But I also want to ship a level editor. I also want to ship something on device. You can go into level edit mode, drag and drop your platforms in and so on, serialize the JSON, maybe share it online, whatever you like. So when it comes to loading these levels in then, I can load in the built-in ones, maybe from an asset bundle, simple as that. But I can also get them from JSON. So I make an empty level layout object. I read all my JSON from a file somewhere, or I download it from a server or whatever. And then I overwrite the object with the JSON data. And after that, I can use that object. I don't have to care whether it's a level that I shipped built in, came from an asset bundle, a level that came from JSON. It's a mixture of the two, even. One of the fun things you can do with JSON overwrite is actually patch part of an object. So I could even have like a level that I ship built in that a user has like customized only the start position, and I load that over the top or something like that. But after this is done, it's just abstracted away all of that kind of concern over whether it's built in or kind of user provided or things like that. Let's look at some reload-proof singletons. So coming back to the domain reload issue. Whenever you recompile code in Unity, we serialize everything, throw away all the managed code, load in the new assemblies that you built, and bring it all back again. So I've got my scriptable object with its C# part and its C++ part. And I've maybe got a static reference to the C# part. So I'm using this as a singleton. Maybe I'm using this to store the current scores of all the players in the game, or something like that. In principle, if I then reload the domain in the editor, if I recompile during play mode, I'm going to lose all of that data. I'm going to lose the static field reference. I'm going to lose the C# object. So we've got some data that's on there. Now, when it comes to domain reload, the data gets serialized through, and then domain reload happens. All the managed stuff is gone. The data is still safe on the C++ side. because this is a scriptable object, it's being serialized. So we then restore the managed part and bring the data back again. How do we get back that static field? Well, we can use find objects of type to then locate that singleton object. Just like searching for a material or a texture or anything else, we can look by type for all the objects that are active, find the one of the type in question that we want to get back. So find object type will then restore that static field for us. It won't do it automatically, we have to call it, but I'll show you a little code example of how this might look in practice. So we've got our singleton class deriving from ScriptableObject. And we have our static field that's going to point to the instance of the singleton that we want to work with. I've made it private because what we're going to do is we're going to access it via a property. And the property is going to make sure that all of this stuff is kind of implemented. So we have the actual instance property there with just a getter. And the first thing it does, if we don't already have that instance field populated, then we'll go and try and find it. We'll go and try and find an instance of our singleton type. If that fails, then we'll make one. You know, we didn't create one of these yet. We didn't have to do it via create instance. I mean, maybe we wanted to do this by going and loading an asset or something like that. Maybe we want a singleton that's kind of ready-made from an asset bundle or from the asset database. And there's something that I think I didn't include on this slide is we'd also want to set the hide flags on it to say it shouldn't be picked up by the garbage collector. We want this thing to kind of live for the whole duration of the session working in Unity. But once that's done, you know, either we found the existing one or we made one. At that point, it should exist. We should have one. So we can just return it at that point. So this is a super simple pattern that will kind of get you these objects that will survive a domain reload that you can kind of keep just referring to. And then after the main reload, you go to access the instance, and it's as if it never went away. Okay? One more closing brace. Another pattern that might be familiar to anyone who's done Mac OS or iOS development is the use of delegates. And this is where I remind you that scriptable objects, like MonoBehaviours, they can contain methods, not just code. And this means that you can use them as sort of pluggable implementation or a strategy pattern. So you have something in the scene that needs to do some work. You plug in a scriptable object that's going to actually do that work, and the object in the scene calls the scriptable object to implement, to do whatever it needs to do. And the scene object maybe passes in itself as like, this is the thing that's trying to get the work done. So the scriptable object kind of knows what to operate on. Because if you're storing a scriptable object in an asset, it can't reference things in the scene. It has to kind of receive those dynamically. And this is true, again, with anything else you store in a project. A prefab that you have in a project, it can't reference things in a scene. You can't guarantee that scene is loaded. It has to be shared. So you can have a scriptable object that operates on things in scenes as long as they're passed in kind of on the fly. So this implements a strategy pattern, as I say. So an example of this. Suppose I have a game, bullet hell, scrolling shooter, or something like that, and I'm picking up power-ups as I fly through. I have a base class for my power-up effect. Oh, that should have been ScriptableObject, actually. I forgot the base class there. But it's an abstract class. On its own, it doesn't do anything. And it has this abstract void apply method. And the idea is that whenever anything picks up a power-up, it's going to call apply. So when I actually have on-trigger enter or something like that for when I hit one of these power-ups, I'm going to destroy the power-up I've picked up, and I'm going to call apply on its effect. The thing that touched it. So that's the kind of abstract base of it. To look at an actual example of then how we would derive from that. So here's something like a health power-up. So we're deriving from power-up effect. We're implementing this apply method, and we have a tunable amount value. So I can have 2 or 3 different health power-up effects in my project. A small buff, a big buff, ultra buff, and even something that removes health as well. I could just have a negative amount value. So I pass in the player object or the NPC or whatever who picked up the power-up as the collector parameter. And then inside the scriptable object, I'm getting the health component, and I'm adjusting the value accordingly. So I'm delegating the behavior of what should actually happen in that power-up off to the scriptable object on the side. And again, you could do this using a prefab as well. That would be fine. But this lets you kind of separate out the actual kind of gameplay consequences of this power-up from all the other details of the collider and the visual aspects and so on. A lot of the value in all of this stuff is in kind of separation of concerns and being able to say, okay, like I want to pull out the audio properties or the gameplay properties to be able to keep them somewhere where my designer or my audio guy is just going to work on those without having to kind of go and trawl through this prefab and find one component somewhere in the middle of it that they want to work on. So here's a second one, insta-kill. It's kind of a harsh power-up, I guess. So you get this one, and we'll make an explosion, and we'll destroy whatever picked it up. So yeah, you don't want to get this one. But again, we can have a whole bunch of different insta-kills with different explosions. You want an ice burst, fireball, whatever. It's the same code, same object type, just different instances configured in different ways, and then plugged into different power-ups. So let's move on to the live demo. So this is based on the demo project that was used at the Boston Training Day last year. It's called Tanks. It's pretty simple, like two-player. You drive a tank around, you try and fire shells at the other player, and you try and be the last man standing. So there's a few things that I'd like to do to that project. So firstly, I'm going to see if I can improve the audio a little bit, because they've got a few audio clips playing kind of repeatedly, but there's some stuff we can do to very, very quickly, actually, make the audio a little bit more impressive. Second thing is I'm going to add destructible buildings, because who doesn't love destructible buildings? Thirdly, I'm going to add pluggable AI. So the demo that they made for training day was purely human-controlled. One player on WASD, the other player on the arrow keys. I'm going to add AI-driven players as well. And I'm going to make it kind of configurable. So do you want to play AI versus AI even? Or two humans versus six AIs, or whatever you like. And we're going to look very briefly as well at kind of configurable game settings with load save. So this is where everything's going to go horribly, horribly wrong. So let us show you to start with the original project. So we've got two players. I've got the blue tank on WASD. I've got the red tank on the arrow keys. And I can fire some shells. You hear how repetitive that sounds? That's pretty dull, right? I can try and take out the red tank. My aim is usually terrible on this, so yeah, there we go. I won. Hooray! Thank you. So let's look then first at improving the audio. And we're using ScriptableObjects to do it. So I'll step forward to some stuff I made earlier. So what have we got here now? So we've got some audio clips. So I went to archive.org. I found some Creative Commons different explosion effects. So I've got a few of these different ones. Oh, pretty loud. OK, never mind. And I've got this audio event, scriptable object type. So get that a bit bigger. So super, super simple, right? It's a basic scriptable object type. It's abstract, and it has this play method. So you pass it in an audio source, and it will play itself on that audio source somehow. So this is an example of the delegate pattern, right? So to go with this, I also then have a simple audio event. So this derives from audio events. This is one particular implementation of this. So this is, so similar to the power-up thing. So a simple audio event has some audio clips that it can choose from. It has the volume it should play at. And I've introduced this ranged float type that is like a min and max float pair, so that every single time I play, I'll just pick a random value in that range, just to vary the volume a little bit. And similarly for pitch, I've also got this ranged float. So I can vary the pitch slightly. Varying volume and pitch is like the bread and butter of beginning to get like audio variation. Super, super simple. And so when it comes to actually playing this audio event on an audio source, so I've had the source passed in. I pick a clip at random. between 0 and the number of clips I've got. I pick a volume value between the min and max volume. I pick a range value, a pitch value between the min and max pitch. Having configured the source, I then play. And that's it, right? So what I've managed to do here is I've grouped together all the parameters that my audio designer is going to care about, and I put them on an asset file that can live in audio events somewhere. So he just focuses on that folder. He doesn't have to worry even about where this is going to be used. He can just focus on, like, he's been told, make a really cool explosion sound for when the shells go off. He just makes this. And then the gameplay designer, maybe later on, will go and wire this up. We also have a create asset menu being applied to this here, which means that I can go now into Unity, and I'll show you. I can go to Unity, I'll go to the assets, create, simple audio event, and it will just be there, and it will just make an asset for me straight away. So, I've done that. So I can come in here, I can create audio events, simple. Okay, so it's popped up straight away. I call that explosion. All right, so I'll lock the inspector and put all 3 of these in here. All right, now let's get some volume in there. It was pretty loud before, so I'll set the volume quite low. Now, pitch of 1 would be kind of normal speed. So we'll start around there, maybe a little higher, actually. Now I've written a custom editor for this, which lets me actually kind of simulate doing this in edit mode. So I can hit preview. Yeah, not bad. But I can hit it a bunch of times. And suddenly I've got a lot of variety in this event. So it's one event. From the gameplay code's point of view, it's just going to trigger this thing, and it's going to get all this different variety of what's going on. And I can tweak this pretty easily as well. I can make it a bit more high-pitched. Yeah, OK. One of those is kind of loud. I should probably take it out. So I'll bring the whole volume down a bit more. That's a bit better. OK. Now, you can imagine as well, it would be quite easy to have other subclasses of audio events that have different approaches to how they pick the sounds. I mean, it's quite easy to end up with picking the same sample twice in a row and similar volume values and similar pitch values. So in that instance, you'd end up with 2 sounds that do sound pretty similar. And maybe you want something a bit more elaborate that very deliberately kind of doesn't use the same sample twice in a row or things like that. You could implement different strategies for this stuff. You could do something that used weighted random as well to kind of control the probability of picking these things. So I'll show you as well the editor code that went with this. So down here. By the way, this project is on Bitbucket. You can go and get all the code there, so don't worry about memorizing everything. So inside the custom editor for audio events, and this, again, is applying to every single audio event. I don't have to write a separate custom editor for each subclass to do this. When I enable the editor, so when I'm creating the editor, I make a hidden game object with an audio source on it that I'll use to kind of be my audition source. When I disable, I clean it up again, because I'm a good citizen. And then in the inspector, I go through and I add this preview button. And all I do for the preview button is I say, play the audio event on my fake audio source. OK? So that's auditioning support in 32 lines of code. I probably have some unnecessary usings as well. Yeah, I probably don't need that, though. Yeah, there we go, 31 lines of code. OK, so I'll move forward a little bit to having kind of set this up already. Right, so I've got my shell explode event. And again, similar thing set up already. I head into my prefab, so I've got my complete shell. I'll look inspector. And yeah, there we go. So I've added in a variable, just a reference to an audio event that should be played when the shell is exploding. So I'll plug in shell explode. Right. Yeah, it's going to be a lot more interesting now with the variety in the sound. So I still think it's a bit loud. I'm going to tweak it here. I'm going to say, OK, the volume's quite low already, but I'll bring it down a bit further. Quieter. Make some other changes. Get a bit high pitched. Okay, high pitch, it's fine. And now I'll exit play mode, and it's kept all the values. Right, so I just did kind of live mixing and audio balancing in play mode. Okay, and that's all saved, and I can check that into version control and share that with the rest of my team very easily. Cool. I even had notes on how I was going to do this, and I haven't needed them, which is brilliant. Cool, okay. So let's look at destructible buildings then. So I'll step forward a bit. We'll go the same. Okay. So again, because this is a scriptable object talk, I've made some scriptable objects. But I've also made a monobehavior. So the idea is that we're going to have the scriptable object, again, act as kind of a delegate. We're going to have a monobehavior in the scene that interacts with the physics system and collision and triggers and things like that in order to kind of make this stuff happen. So to show you then very briefly in here. So here's the monobehavior. So I'll attach this to any object in the scene that I want to be destructible. So all the buildings, anything else. The tanks already have their own kind of custom stuff, so I'm not going to mess with that. But for basic objects that need to be in the scene, have some health, and when you run into them enough times or blow them up with shells enough times, they want to do something, I'll put this on it. So we're going to store a health value per building. Obviously, that's not shared state. The damage per tank collision, yeah, in principle, that could have been shared. In practice, the buildings are kind of diverse enough that I'm going to set one of these separately for each building. And I have a reference to a destruction sequence, and that's going to be my scriptable object. So there's a take damage function, and I've changed the shell script in here as well, that when it impacts with something, it sends a take damage message to it with 10 points of damage per shell or something like that. So this is how it's going to kind of receive that. So if it's already been destroyed, health is less than 0, don't do anything. Otherwise, knock off some health. And if it's now less than 0, and we've plugged in a destruction sequence, we're going to start a coroutine that is in the scriptable object. And this is a fun thing about coroutines as well. They're just code, right? They're just a function that returns an enumerator. And they can live anywhere. You don't have to define a coroutine on the same monobehavior you run it on. So the monobehavior is going to be responsible for kind of holding that enumerator, stepping it every frame, and kind of making the next bit happen. But the code is going to be in a different class entirely. Okay? And yeah, so we also have on collision enter. So if you drive into one of the buildings as well, we'll also take some damage from being run over by a tank, which seems fair enough. So destruction sequence then, again, it's an abstract class deriving from scriptable object. So it's another delegate pattern. And you see this time, so I'm passing in the monobehavior that it's going to run on, and it's going to return an enumerator, which is the actual coroutine instance that can be stepped through. So if I step forward then to a slightly more completed version. Right. So now I've got a couple of actual destruction sequences made. So we have a controlled demolition. And this, I've given it a bunch of parameters. So I spent a while tweaking this because it's really fun to watch buildings fall down. So we've got, is it going to shake around? Is it going to kind of slide into the ground or just scale down? Is it going to have dust effects kick up and all the rest of this stuff? So I have this coroutine, then that actually implements the effect. So I'm passing in again the monobehavior from the building that kicked this off. And so I'm able to go through. I'm able to grab the transform. So I can set up things like the position of my dust effects and so on based on the object that's kind of executing this. Yeah, so I've got my particles, kick them off. If we're collapsing it, then play some collapse audio events. A whole bunch of stuff. It's not worth kind of going through it in a lot of detail. It's even camera shake in there because I'm good. And then there's a slightly more simple one, which is just spawn some kind of big particle effect and hide the building behind the effect. So you get a big dust cloud, and then when the dust clears, the building is mysteriously gone. So much more simple. Make the effect, wait for a certain amount of time, and then destroy the original thing. Pretty easy. Now, if I go in and I want to start actually using some of these things, so I've got instances of them set up already. So I've got big building, small building. The radar tower is always a great one. I'll do that one. So I put the destructible script on here already, and I'll just plug in that radar tower effect. So when you look at the radar tile, yeah, so it's going to take 5 seconds to come down. It's going to slide into the ground and stuff. So give that a try. Oh, my aim is terrible, I told you. Yeah, there we go. That's nice. Yeah, I like that. That's good. And I can maybe grab all the small buildings as well and say, well, these should all have the small building destruction sequence, but maybe that one should just have like a big explosion, etc. So I can have like a whole library of different collapse things that maybe my effects artist has gone through and kind of tuned and tweaked and made lovely. And then I go through and kind of just decide, okay, I'm just going to throw these things wherever and it will be great. So that's destructible buildings. Now let's move forward to the AI brains. So initially, we've got human-controlled characters. We've got 2 tanks. We've got player 1 and player 2 controls. And the only difference between them is which input axes they read from, right? So I've got a couple of scripts in here. So we have this tank brain. And again, we're doing this as a kind of delegate object pattern. You can tell I quite like that pattern. And so initially, when the game first starts up, when the round first starts up and the tank is made, we'll initialize the brain. So that's what I'm calling these things, different brains. So the idea is that we'll plug in like a player brain, or an idiot brain, or a sniper brain, or a commando brain, or whatever, and they'll behave differently. So we get initialized when the tank is first created and the brain is first plugged in, and then every frame we're going to get a think callback on our scriptable object that makes the decision about what the tank should actually do. And in the case of the player-controlled stuff, it's very, very simple. This has pretty much just been taking the code for moving the tank that was already in there and kind of just refactoring it out, extracting it into a scriptable object. So the think step steers the tank according to the input axes, so checking horizontal and turn. And then if it's shooting, it starts charging the shot, and if you've let go of the button, then it fires the shot and stuff like that. So we've provided these 2 components, tank movement and tank shooting, that allow the brain to kind of control the mechanisms of the tank, movements, charging the shot, releasing the shot, etc. The brain makes the decisions about when they do these things and how and where and so on. So if I step forward now, okay, so now I've got two more brains added to the project. A simple sniper who's going to pick a target, turn towards it, charge a shot based on some guess about how much it, some proportion about how far away it is, and then fire it. And we've got a random walker who's just going to like turn for some period of time, move forward some period of time, and then fire some arbitrary distance. So, having done that, I can go into my game manager here. So I've got my 2 tanks, and there's no brains plugged in right now. So I've got instances of these brains. So human 1 and human 2, using human-controlled brains, and then player number just to kind of control which set of input axes it reads from. I have the idiot brain, which is the random walker. And again, I can tweak, how long does he sit still for, how long does he move for, and then how long does he charge his shots for. I have the sniper, who again is going to, I can control, how often does he change targets, how accurate is he, stuff like that, and how frequently does he fire. When I first made this thing, he was firing like every 0.1 seconds. It was very, very hard to win at all. I can probably show you that, actually. So I'll put in human 1 still so I can still play, but I'll play versus the idiot. And maximize. Okay, so once it starts, away he goes. You can see why I call him idiot, right? Although I'm not much better. There we go. Come on, sit still. There we go. Okay, well, I've knocked out his health. But, yeah, so you can see. And now if I maybe swap him for sniper, I could swap myself for sniper even. We'll be here a while, though. Okay, so up. Right, so the sniper is just going to keep on. Yeah, he doesn't really understand obstacles or movement. So, yeah, potentially lethal if he has a clear line of fire. Yeah, we could watch that for hours, so I'm not going to stop. Yeah, okay. Right, and I'll show you one last thing. We're running out of time, so I really got to go quickly. So one of the last things then is expanding this kind of single scene that just plays forever and ever and ever and ever into something that's maybe a little bit more kind of beginning, middle, and end, a full presentation. So I've got my main menu scene, and I have to set up something quickly because it broke and I don't know why. So my prefabs and stuff. Right, the name goes in there, color goes in there, brain goes in there. Okay, good. Yeah, right, so I've made a little kind of front-end menu. I'll fire this up. So not got names for any of these things, so I'll type in, I told you it would all go horribly wrong. Okay, well, the idea here is that we've got game state. So we're setting up the name of the player, the color that they're going to have, and which brain they're using. And that all actually can get saved out to a JSON file. Well, that should be loading from there. Let's see, does it work if I do it a second time? It doesn't. OK. I can maybe control the number of rounds as well. So we'll say 2 rounds in the game, and then play. Now, when I hit play, one of the things that's just done is it saved those settings to a JSON file. I can just open that up quickly with Sublime. And so you can see, yeah, OK, even though it wasn't displaying the names of the players and stuff, it did actually kind of have it in the data model. So I've been able to save through then all that information. And in principle, if I fire it up again, if the UI working correctly, at least, it would load all this stuff from JSON instead of loading it from in the project. So instant load save of kind of game settings. And you see number of rounds. So I did set that down to 2, and it's got that there correctly. OK. Yeah. So that's kind of a little example of dual serialization. So I've got like the default settings you might expect when starting a game, or it can load it from JSON when you start the game. So, cool. Right. I will very, very quickly finish. So in conclusion, ScriptableObject is a vital tool in your toolbox. It is only a tool. I mean, I'm not saying give up on MonoBehaviour entirely. You will need it sometimes. But it's definitely something you should know. You should understand what you can do with it and consider it when you're kind of designing your architectures. It is very simple, but it's pretty flexible. And you can build really nice architecture and some really, really nice workflows for working in your team, working with your artists and designers. Thank you.